Okay, on the law sines, law cosines worksheet, these are the word problems. I'm going to draw the picture for number 11, but I've already done a video for 10. These two things are almost identical. They're very similar in how you do the steps. And I would know how to do this for the test if I were you. So I'm going to draw a parallelogram. So your parallelogram looks something like that. The opposite sides are parallel. It says one side is 24.6 and the other side is 38.2. Now from geometry, you're supposed to know in a parallelogram, opposite sides are what? Anybody? Equal. So this side down here is also 38.2 and this side over here is also 24.6. And then it says there is one vertex angle that's 108. So we're going to say this one is 108. And you're supposed to know that in a parallelogram, opposite angles are what? Equal also. So this angle down here is also 108. And does anybody remember what the adjacent or consecutive interior angles are for a parallelogram? Anybody remember? What? They don't add up to 360. That's too much. They do add up to something. 180, they're supplementary. So 180 minus 108 means this angle is 72 and this angle is 72. Now, do you remember what a diagonal is? Okay, you guys should have been watching videos last night instead of not knowing what's going on, because I told you we'd 10, well, maybe I did because I did it after your class, but number 10's there. A diagonal is a segment that joins two non-adjacent vertices. So if I look at this point, this is adjacent to it, and this is adjacent to it. So this is non-adjacent, it's not right next to it. So this right here is one diagonal. So you got to find that red line is one of the answers you're looking for. So what you want to do is you want to draw that triangle using the red line. That's supposed to be the red line. And then I got the triangle looks like this. Okay, so that red line corresponds with this part right here. I'm going to make it red. That red line's that thing. And we're looking for that. That's what we want. And we know this is 24.6. We know this is 108 degrees. And we know this is 38.2. So what am I given in this triangle? Side angle side. What do you got to use? Okay. Law of cosines. Yeah.
How do you know to draw the diagonal that way?
Okay, I've got to find both diagonals, right? That's only one diagonal. I got to find the other one too.
So you have to find them.
Yeah, I got to find both. Find the lengths of the diagonals. There's a plural there. So that's only one of them. So I got to do this to find that diagonal. And then there is another diagonal on there. Put that in purple. This is the other diagonal that I have to find. So I'm going to draw this triangle. I need this triangle right here. Got to do that triangle. So I'm going to draw that one down here. And I'm going to make this the diagonal part right there. And then I've got this side and this side. Well, I know this side over here, 24.6, is this 24.6 right there. This side down here is this 38.2. And then this angle right here is 72 degrees. And then I got to find that diagonal right there, that Y. You can call it whatever letter you want. If you want to label this triangle ABC like this, you can, which means this would be ABC like this. Okay, and then this would be D. So that would make this X little b. Okay, and if you had this one over here, you got A, and you got B, and you got D. Now instead of ABC, you're using ABD, so this side over here is little d. This side over here would be little a. You understand what I'm saying there? Yes, sir.
Why can't you tell what angle B is, like for the second triangle? Why can't you tell what angle B is?
Well, you could.
Could you just let them?
You'd have to do SOHCAHTOA, or a law. You'd have to do law of sines and cosines to find this angle, but it would take a lot more work to find that angle. Because there's that angle, this little angle right here, you're talking about, right?
Yeah.
Well, that little angle right there is, if this diagonal, you're talking about this angle right here.
Right.
So this does not bisect, diagonals do not bisect angles in parallelograms. So it's hard to find. But you could find it if you just took this triangle right here and did law of sines and law of cosine stuff. You can find all the missing parts and you can get it there. But we don't need to do that much because all we're looking for is this purple line, the diagonal.
Yeah, I was just curious because there was parallelograms, so I was wondering if it.
They do not bisect. Now in a square and a rhombus and a kite, all of those diagonals do bisect angles. Those were rules or theorems you were supposed to learn back in geometry. But in a parallelogram, just a regular parallelogram, they do not bisect angles. Yes?
How do you find the angles of like 108?
How did I find 108? It said right here, one of the vertex angles is 108.
No,
It gave it to me.
not that. Whenever you split up the triangle, how do you figure out the other angles?
I don't need the other angles. I am trying to find, like I said, I drew in here this red line. That's a diagonal right there, right? This says find the lengths of the diagonals. I need the length of that red line. So I redrew the red line right there. That's what I need. I do not, because this is a side, this is an angle, this is a side. I'm given side, angle, side, and that's one of the ones that lets you use law of cosine. The other one for law of cosine is side, side, side. You can find all the angles in there, because once you get this side, this diagonal, you can do law of sines to get these two angles right there, but you don't need them. They're not asking for those. So you'd be doing extra work. You understand what I'm saying? But you will have to find this x first, this red diagonal. But that's all you need on this problem. They want the two diagonals.
So you use cosine only on side by side and side angle side.
No, yes, that's correct.
And then you use sine for
Everything else. That is correct. Anybody else got a question on this picture, this problem? And again, I did more, well, maybe I didn't. I might have just set it up exactly like that for number 10 too. I don't think I worked them out because I want you practicing. Okay, so that was 11, and I think you guys want to see number 13 as well, right? Yeah, oh my gosh, this looks familiar. Okay, so this says you have a parallelogram again. So I'm going to draw a parallelogram. And it says one side is 28. It says another side is 42. And this says the longer diagonal measures 58. So we're going to put that over here and say this, because that's longer there than the other one. That's 58. Find and measure the angle at the vertices. Okay, so we need to find these angles. We got to find this angle, right? Maybe I should label all these. Now, once you find A, what other angle do you have? Once you get this angle A, because this is side, 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 what other angle do you already have? C. This angle A and angle C are the same, right? So all you got to do is use law of cosines and find angle A, and then you have angle C, so you can say angle A equals angle C equals whatever it is to the nearest minute when you set this up, because this is side, 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 so you're going to use law of cosines. Are you thumbs up, Tommy, or thumbs up? Cody, no?
No.
No one? Okay. Harvey? All right. Now, so you're going to get this angle. Do you have to do law of cosines to get angle B? Now, we need this angle B over here and this angle D, which are the same. Do we need law of sines and cosines to find those? No, because do you remember what we just said over here on this problem? We said that the adjacent angles were what? Supplementary. That's something from geometry. And like I said, I love math because the rules don't change. So if you know your rules, you don't have to do the other triangle. Okay? Are you thumbs up with me or not? So this one, to me, this one is easier because I only got to do law of cosines once and get this angle, and that gives me all four angles. And then you're going to say angle B is equal to angle D is equal to whatever to the nearest minute. And again, this one and this one have to be supplementary. So when you find this angle, you're going to take 180 minus that angle And that will give you this angle, these two angles down here. Yeah,
So whenever you're trying to like work it out and you're using one of the cosine formulas for side angle side, how do you like plug it in?
okay, well, let's do the equation. Now, I said side angle side, which formula are you gonna use? The a squared one, right? All right, so let's go back over here, and I'm gonna do one of these for you. I'm going to do this top one. What did I tell you was the most important thing for law of cosine? What's the most important thing? Anybody, everybody? The angle, not the biggest, just the angle. Which angle do we have in this triangle? 108, so we're going to do the B one. So the B one says that little b squared is going to equal the other two sides squared. And because I got C here, this is little c. And since I have A here, this is little a. Down here, this is D. So instead of, on this one, you're going to use A, B, and D, not the C. So it's going to be this minus 2 times the same two sides cosine of the B. And the whole reason I'm using this formula is because they gave me this angle that I call B. If you put an A here, then you'd use the A squared one here. So whatever letter you use here is what letter goes here and way over here. And then whatever letters you use here and here, the lowercase of those go in here. You understand what I'm saying?
Yeah, but that's not the question that I asked.
You said, how do you know which equation to use? I thought.
Like on number 13, because it's in a parallelogram. And
Okay. What triangle am I going to look at to get A? Can you pick a triangle out of this from this picture? You can. Which one? Which one? I would use the top one because I put the numbers here. Do you want to come down here and make that 42 and 28 and use this bottom one? You can use the bottom one. But you just draw one of the triangles. So if I draw the top triangle, that's A, that's D, that's B. You know, this is 28, this is 58, and this one up here is 42. So which one are you going to use out of the sine formulas? Cosine A is right. You're going to get cosine of A because that's the angle I want. And then you're going to plug in the other side. Now remember, this side over here is little b. This side 42 is little d. So I would have b squared plus d squared minus a squared all over 2bd. Because I'm using d's instead of c's. You see how that works? Yes or no? You can't see thumbs. Everybody see how that works? So you see what you can do? You just draw the parts you need to help make a triangle. Yeah.
You get the angles from, you get the first angle and then you get the other one by minus.
On a parallelogram, yes, because consecutive angles in a parallelogram are supplementary. That's a theorem that you guys did when you worked on your quadrilateral stuff. Now, most of you probably don't remember that. Yeah.
Can you go back to the other one?
Okay. What you got?
I just want to see it. Thank you.
All right, I'm going to stop this video because it's getting too long.